This video is for the central and inscribed angles notes. This is lesson 6.2. All right, let's look at central angles, okay? Central angle comes from the center of the radius, and the two legs of the angle hit the edge. So both of these legs are a radius of the circle. All right, so an central angle is an angle whose vertex is the center of the circle, so that's the vertex, and whose sides are radii. That's plural for radius. This is a radius, this is a radius. The measure of a central angle is equal to the measure of the intercepted arc. Okay, so name the central angle. BAC. Remember, the vertex is always in the center. Or CAB. Either one doesn't matter as long as A is in the center. The intercepted arc, so that's this piece right here. So we write an arc and we say BC. That's the name of the arc. The measure of the intercepted arc is equal to the measure of the central angle. So BC has a measure of 53 degrees. Okay, central angle, intercepted arc have the same measure. All right, an inscribed angle is an angle whose vertex is on the circle. So now our vertex is on the circle, and whose sides are chords. So a chord does not go through the center, so it's not a diameter. You can see here, it just goes from one edge to the other edge without ever going through the center. So the measure of an inscribed angle is 1/2 the measure of the intercepted arc. An inscribed angle in a semicircle, so that's half a circle, is a right angle. So if we do this in half a circle, it's going to be a right angle every time. The measure of an inscribed angle is half the measure of the central angle that shares the same intercepted arc. So what that means, if I wanted to do a central angle here, where the vertex is here, here's the intercepted arc, right? From here to here. So if I did an angle, it looks like 180 degrees, okay? But again, visually, that's deceiving. If we knew the measure of this angle here, of this central angle, we would be able to find the measure of the intercepted arc. But going just off of what we have, we can find our information. So the inscribed angle is RSQ, or QSR, as long as S is in the middle. RSQ. The intercepted arc, so here's where it ends, here's where it ends. It's the distance between those two. That's the arc, RQ. The measure of the intercepted arc, so go back to this. The measure of the inscribed angle is half the measure of the intercepted arc. Here's the angle. This measurement is half of this one. So to work backwards, we would multiply by 2 to go the other way. So if we do 95 times 2, we would get 190 degrees. So this distance here, see if I can get it to show up, all the way around here, would be 190 degrees. So that's it for this video.